So, Chapter 5, test review, starting off with number 1, simplifying radicals. So here we have one big radical. Remember when we simplify radicals, we make a good and a bad to split it up. Okay, so we take everything one at a time. What is a perfect square that goes into 75? And again, I have the list up there for you. 25. So then 75 divided by 25 is 3. Okay, so we split up our whole number. Now we take our variables. In order to know how many are good, what are we looking for? We want the highest even number. So out of 3, how many of those are good? Yep, 2. How many are left? 1. What about y to the 5th? Yep, y to the 4th. How many are left? 1. And then what about z to the 4th? All of them, right? Z to the 4th. Are there any that are bad? Nope, and it's okay to not have any that go there. What's the last thing we have to do here? We have to simplify the good. What's the square root of 25? 5. What's the square root of x squared? Yep, remember what are we doing with our exponents on these? Dividing by 2. Yep, so that's how we get x to the first for this one. What about y to the 4th? Y to the 2nd, because 4 divided by 2 is 2. And then same thing for z, we get z to the 2nd. What do we do with the rest? We keep the bad. All right, number 2 says multiply. Here we have 2 binomials. What I mean, we have 2 sets of parentheses that have 2 terms in them. What do we do to solve this here? We have to distribute. So if I start with square root of 3 times square root of 3, what's that turn into? Square root of 9. Remember, we're multiplying. Square root of 3 times negative 3. Negative 3, square root 3. Remember, we can't combine our whole numbers and our radicals to make one radical. They have to stay separate. Okay, and then here, 2 times square root of 3. Plus 2 square root of 3. And then 2 times negative 3. Negative 6. Remember, we're multiplying them. So once we have it all multiplied out, this is just where the simplifying comes in. So if I look at this, what's the square root of 9? 3. Can I do anything to simplify square root of 3? Nope. So I'm just going to keep what I have here. What's the last thing we're always going to look for when we simplify? Like terms, right? Does 3 have a like term? Yep. 3 minus 6 is negative 3. And then what about these two? Do you agree those are like terms? Why are those like terms? They have the same radical here. So we combine like terms. What's negative 3 square root of 3 plus 2 square root of 3? It's negative 1 square root of 3. Remember, the radical stays the same. I'm just combining the coefficients. Number 3, A and B, we're simplifying the expression. So here they have it written in exponential form right now. We want to break that apart. What can I represent 2 and 3 as? Power and root. Which one's the power? The top one's the power. The bottom one is the root. So if I rewrite this, my root is 3. So we have the cube root of 64 to the 2nd power. Yep. So now we can actually evaluate this. This is where you use your calculator. Again, if you have questions on how to use your calculator tomorrow, you can ask those and I can help you out to make sure you're doing it right. Okay, so what is the cube root of 64? 4. And then we still have squared. What's 4 squared? 16. And then B, do you agree it's the same thing? Okay, so again, the 3 and the 2, which one's which? Power's on top. Root is on the bottom. So if I rewrite this, if 2 is my root, then we have the square root of 36. Do I need to have this 2 here? Nope, I can, but it doesn't matter. And then to the what power? 3rd power. So evaluate, what's the square root of 36? 6 to the 3rd power is 216. All right, looking at number 4 next. It gives us a graph, and then it tells us what directions it's moving. So here, this is our parent function. That's our regular function. Remember, parent functions always start at 0 on a graph. Okay, so here it tells us we are going right 3 and down 9. So if I rewrite my function here, I have y equals the square root of x. Well, what's happening with our x values? Remember, x is left and right. We're going right 3, and we have to flip it, right? So right 3, how do I write that in mathematical terms? Right 3, we would think plus 3, but remember with x's, we have to think opposite, so it's got to go x minus 3. And then how do we represent down 9? Minus 9. Yep. So over here, if you want to write some notes, if it ever says right, we're going to subtract. If it ever says left, we're going to add. What are we going to do if it says up? Add, down, subtract. Okay, and remember, these two are with the x. These two are the y. Number 5, it says it wants to write an equivalent expression. What that means is it just wants us to write this in a different form. So we're really going backwards from what we were doing on number 3. Okay, so what's this 3 right here? That's the root. What's the 4? That's the power. So I'm going to keep my base term, 17. So then how do I write the 3 and the 4? Yep, power over root. So 4 over 3. Okay. And then that's all that one wants you to do, just to rewrite. Okay. Number 6, this is the most fresh in our brain. What is the inverse? Now remember, there were 3 steps to finding inverse. What was the first one? Change f of x to y. What was the second thing? Switch x and y. And then 3 is, last step, solve for y. Okay. So let's follow those steps here. Step 1, we change f of x to y. So this turns into y equals 64x cubed minus 1. Step 2. Change the x's and the y's. Is anything else changing in this step? No. Nope. These are just switching positions. And then finally our step 3 is solving for y. Okay, now keep in mind we want to get y by itself. So what do I need to do first? I need to add 1. On this side, is that going to turn into 1x or something else? It's going to turn into x plus 1 equals 64y to the third. What should I do next here? Yes, one thing I want to talk about real quick. A lot of us want to cube root this first, but remember, in order to do that, we have to get this by itself first. So we have to divide by 64 on both sides before we can take the cube root. So, again, are the inverses always going to be very nice? They're going to look a little messy. So on this side, you can just keep this as one big fraction. So x plus 1 over 64 equals what's left on the right? Y to the third. Now, what's the last step here? Take the cube root. What do you do to one side? Do to the other. So again, this can just stay how that is. So we're left with y equals the cube root of x plus 1 over 64. And again, we don't have to worry about simplifying or anything on this side. Our main goal is to get y by itself. So once we have y by itself, we know we're done. So on number 7, this is very relevant to number 4. Okay, so what I want us to do first is, in order to know what our transition graph is going to look like, we have to know what our beginning graph looked like first. So write down your parent function. Our parent function is that f of x equals square root of x. Okay, so we want to graph that. When we did this lesson, we went through an XY chart. Where do parent functions always start on a graph? They always start at 0. Okay. If I plug in 0 to this function, well, what's the square root of 0? 0. Okay, so we have a point at 0, 0. Now we need some other values here. how do I determine what values I'm going to use? Give me a random number. Okay, let me try 2. If I plug in 2 into this function, is it going to come out nicely? Because what's the square root of 2? Right, there's not a perfect answer for that, okay? So what kind of numbers do we want to use for this? Right, we want to use perfect squares here. So let's just do 0, 1, 4, and 9. So now if we plug those values in, what's the square root of 1? 1, what's the square root of 4? 2, square root of 9? 3. So again, what this table gave us is these are ordered pairs for our graph. So if I graph this, we have a point at 0, 0. Remember, always graph the x first. We go over 1, up 1, and then over 4, up 2. And then I know we go off the graph, but we would go over 9, up 3. And then go ahead and connect your graph. Is the parent function ever going to look any different? No, parent function is always going to stay the same. So now, once we have that graphed, this is when we look at what's happening here. Okay, so compared to our parent function to here, what's happening? Like, what's this 3 tell us? What's that 3 tell us we're doing? First, is it with the x or is it outside? It's outside, so we're dealing with the y. What does it mean for a positive 3? We're going up 3. Yep. So up 3. Is anything else happening? Nope. So this is our rule. What am I going to do to get my new graph? Move every point up 3 with our rule here. So up 3 for each one. And then connect. And then you're done. So same rules as number 4 over here. You can refer to those rules to help you. Okay. Number 8, it says multiply. It is very similar to number 2, but what kind of makes this one a little nicer? Right, and we only have to distribute one thing. So if I take square root of 2 times 2 square root of x. Close. What's the number technically in front of here? A 1. So remember, we multiply our whole numbers. 1 times 2 is 2. And then we multiply what's inside our radicals. What's 2 times x? 2x. So we get 2 square root of 2x plus, now we have square root of 2 times square root of x. Square root of 2x. Good. Yep. And then always check if you can simplify. Can I simplify? Because, right, these radicals are the same, so we can combine like terms. What number is here? A 1. So if I combine both of those, what's 2 square root of 2x plus 1 square root of 2x? 3 square root of 2x. Do you agree that number 9 is very similar to one we've already done? It's pretty similar to number 5, right? So this is where we just want to write it, any expression that's equivalent to that. So just rewriting it in a different form. So again, what is this 3? That's the root. What do I not have? A power. But what is technically that power if there's nothing there? 1. Yep, so 1 is our power. Yep, so now we keep our base here. So we have negative x. And then how do I write my exponent? Power over root, so 1 over 3. And again, we're just rewriting the expression. Moving on to number 10. This is where our compositions come in. So they give us 2 functions. They give us our f of x, and they give us our g of x. We want to find f of g of x. So if I write this here, how do we start with these? What's the first thing we need to do? Right, we need to do that inside first. Do I know what g of x is? What is g of x? 3 minus x. So this now turns into f of 3 minus x. So now, what do I do with this 3 minus x? Plug it into that f function here. So now this turns into square root of what? 3 minus x. So all that happened was I took this right here and I plugged it in for the x there. Remember, it replaces the x. It doesn't go with it. It replaces it. Now, normally we see if we can simplify. Can I simplify this at all? Nope. So this is my answer. That's my composition. Number 11, we are dividing. What is the main issue with what we have right now? It's a fraction. And remember, what can we not have in the bottom? We can't have a radical in the bottom. So, remember, we multiply. What are we multiplying by? Not exactly the bottom. What do we have to do to the bottom? Yep, it's 3 minus the square root of x. Remember the conjugate. And what we do to the bottom? Got to do the same thing to the top. So the only thing that's changing there is the sign that's in front of the radical. Everything else is staying the same. What I would do here, put these guys in parentheses, because what are we going to have to do? We're going to have to end up distributing. Okay, so if I distribute on the top, I have square root of x times 3. 3 square root x. And then I have square root of x times negative square root of x. Negative square root of x squared. On the bottom, we distribute again. So 3 times 3, 9. What's 3 times negative square root of x? Negative 3 square root of x. Here we have square root of x times 3 plus 3 square root of x. And then here we have square root of x times negative square root of x minus the square root of x squared. So now we're to the point where we are simplifying. What always happens? Yep, these ones are going to cancel out to 0. If they didn't, did you do something wrong? Yes, you always want those to cancel out. And this last one right here should simplify for you. What's the square root of x squared? Remember, think back to what we did on number 1. What do I do with the exponents? I divide them by 2, right? So what's the square root of x squared? 1x, right? So we have 9 minus x left on the bottom, because this right here turns into x, negative x. And now let's look at the top. Can I do anything with 3 square root of x? Nope. So this stays as 3 square root of x. Again, what does this turn into? What's the square root of x squared? Negative x. Yep. We cannot cancel these out because they are split up by subtraction. If they were multiplying, then yes, we could cancel them out. Yep. But since we can't simplify any farther, that is our final answer. Let's look at number 13. On these, we are solving. This should say solve. We are solving each expression. Okay, so what that means is we are going to get an actual value for the variable. Okay, so on A, normally we want to get the radicals and the exponents by themselves. What do you notice on A? We have more than one radical, right? Are they both by themselves? Okay, so what can I do to get rid of those? I'm going to square both sides. Again, what I do to one side, I got to do the other. Again, look what happens. These cancel, so I'm left with the inside, 3x plus 22. And then same thing on this side, 2x plus 16. Yep, I can start by subtracting 16. So I have 3x plus 6 equals 2x. What do I need to do next? Subtract 3x. So we get 6 equals negative x. Is x fully by itself yet? No, it still has that negative 1. How do I get rid of it? Divide by negative 1. So we get x equals negative 6. And then part B, what's different about part B? It's a fraction as an exponent, right? So we want to make sure it's by itself. Is it by itself? Why can we say it's by itself? Right, it has the parentheses here. That means everything is to that power. So how do I get rid of that exponent? I flip it to the opposite. So 3 over 4 becomes 4 over 3. What I do to one side, do to the other. So looking at the left side, very similar to what we did on number 9 and 5. How can I rewrite this here? Cube root of 27 to 4th power. And then what happens to the exponents over here? They cancel, so I'm left with the inside. So now let's look at that left side. What's the cube root of 27? The cube root of 27 is 3, and 3 to the 4th power is 81. So we get 81 equals negative 7 minus 4x. And then now it's just an algebra problem. How do I solve? Add 7. So we get 88 equals negative 4x. Divide by negative 4. X equals negative 22. Number 14. We're evaluating functions. Okay, so let's just jump right in. On A, how do I find f of negative 2? What am I doing with this negative 2? Yep, I'm plugging it in for the f function. So this turns into negative 6. Is it minus 2 or times negative 2? Times negative 2 plus 3. What's negative 6 times negative 2? Positive 12 plus 3 is 15. Okay. B, we have g of 3. What do I do with that 3? Plug it into that x, being careful with that negative that's still there. So this turns into negative 3 plus 3 over 6. So now simplify. What happens on that top part? Negative 3 plus 3. What's negative 3 plus 3? 0. So we have 0 over 6. What's 0 divided by 6? 0. Yep. Any 0 divided by any number is always 0. What's different about C? Right, it's f of g of 2. So we want to do the inside first, right? So if I want to find g of 2, what do I do with that? I plug 2 in for g. So this turns into negative 2 plus 3 over 6. Well, what's negative 2 plus 3? 1 over 6. Now, what do I do? What do I do with that 1 over 6? Right, remember this replaces this, so we turn into f. This turns into f of 1 over 6. There we go. So I'm plugging the 1/6 into the f function here. So this turns into negative 6 times 1 over 6 plus 3. What happens here with that negative 6 and 1 over 6? The 6's cancel. So don't forget we still have this negative though. So this turns into negative 1 plus 3, which is positive 2. 15 says state if the two functions are inverses. So again, what are we looking for? There's two things. What do we have to do? There's two things we have to find to know if they're inverses. We have to find f of g of x, and we have to find g of f of x. Now, a lot of you are going to want to do the 3 steps to find the inverse, but we already have two equations. So we're not finding the inverse, we're stating if they are inverses. Okay, so first thing I want to do, I want to find f of g of x. Okay, well, what do we do with, do I know what g of x is? Okay, so we plug g of x into here. So we have f of negative x plus 3 over 6. What do I do with that negative x plus 3 over 6? Plug it into the f function. So this turns into negative 6 times negative x plus 3 over 6 plus 3. Again, what's kind of nice that happens? What happens to the 6's? They cancel. Again, being careful with this negative here. We got to distribute that in. So that turns into x minus 3 plus 3. And now simplifying this, what happens? Right, these cancel out to be 0, so we have x left. So remember on these, you're just simplifying. You're not solving an equation. You're just simplifying. So underline that for me. That's important to us. Now, what do we have to find after we found f of g of x? We have to find g of f of x. So again, first thing, what is f of x? Yep, so we have g of negative 6x plus 3. And now what do we do with that negative 6x plus 3? Plug it in for g. Yep, the x is in g. So what this turns into, being careful with that negative on the outside, we have negative 1 times negative 6x plus 3 over 6. What do we have to do to simplify here? Right, we have this negative 1 in front, right? So what do we do with that? Distribute. What happens when you distribute a negative 1? Changes the signs, yep. So we have 6x minus 3 plus 3 over 6. Keep going. What happens on the top? The 3's cancel, right? Because they get 0. So we have 6x over 6 left. Right, because what happens with the 6's? They cancel, so I'm just left with x. What does that tell us? They're the exact same, so that means yes, they are inverses. If they are not the same, then what's your answer? No. Yep.